areas, interesting language technologies, and to get students involved throughout their undergraduate careers in real projects with research or maybe with their communities, and use computer science for those. In terms of providing the deeper understanding, we wanted to focus on the fundamentals of computer science and developing software. At the same time, we wanted it to be language agnostic. That is, we didn't want to go in and teach 2 years of a particular programming language. The language was not the point. The concepts, the fundamentals, the ability to think about how the computer is solving the problem for you, how you're going to communicate with that computer was key and something that we changed. The other thing that we changed that we feel really strongly about is that as we introduce potentially complex concepts, we would revisit them with more and more in different scenarios throughout a very well integrated 2 years of lower division, so that by the time they got to the upper division, they had a real thorough understanding, lots of experience with more challenging concepts. We would introduce them early, give them a high level understanding, but we would give them lots and lots of practice and show how these key issues, these key concepts were important throughout. You build skills that way. And then throughout the curriculum, we wanted to integrate modern software engineering tools, methods, and processes. So this is how our new curriculum looks. The nodes in dark are, you don't have to recognize the numbers, but the nodes in dark are the core. This is what we really wanted to emphasize, have a whole year of just classes that just built on each other, that reduced redundancy, but gave the students a thorough understanding of the concepts of building software for modern systems. If a student comes in and they've never programmed before, they would take a class, the CS8 class. It's at the top right on your screen. It's just a high-level introduction to programming. It doesn't teach a language. We do it on a very high-level language, Python or Ruby, something very exciting. Very exciting. We emphasize. We want to encourage students to, be excited about computer science, what computer science has to offer, all these other disciplines that we've talked about today, and it's really about getting them, just giving them a sprinkling of the potential of computer science. It's very fun. It's very graphical. It's very high level. We take them through a lot of program development using a high-level language very early. Our core is about problem solving and computational thinking. It's not about a language, it's not in Java, it's not about Java, it's not about C or C++. It is about being able to communicate to the computer what the problems are, the algorithms are that you want to solve. And this is, of course, hard to do because you're doing it in a language, but we really wanted to de-emphasize that and emphasize that the language is a tool. And therefore, our goal is, over time, that our students can pick up any tool. They can go to any company and work on using Java or using Python or using Ruby on Rails or using C++, and they would be well off. So we start low level. We have gone the opposite way. So with Java, we started at the very high level. And we never really discuss how those programs actually operate on hardware today, how memory is being managed, how the CPU is being accessed. And so we're starting with fundamental building blocks from the ground up. And we're going to add abstraction over time, over this 4-class series, 16 through 48. It is a language, the syntax of which looks like C. It's not the C compiler, though. It's not the building of a complete piece of software. If you look at why people are so excited about these high-level languages today, like Python and Ruby, I would say that part of it is because the development cycle is so fast. You have a graphical development environment, you type in a few lines, and it tells you where your bugs are immediately. It executes it as you're typing, right? You don't have to have a compiler and sit there for however many seconds to wait for the binary to be finished and then execute that binary. You don't understand what's going on. You immediately get feedback about the instructions that you're typing, about the algorithms that you're putting in, and you know whether you're communicating with the processor or not, correctly or not. And so we have a framework like this. where we can eliminate compilation and linking and loading and all those concepts until the students have the maturity to understand what that is. And I think that is key. It is low level. At the same time, we don't introduce the concepts for which they don't have the maturity to understand. And then we build up from this low level in increments of more and more abstraction. We go to more objects, we start introducing objects later and data structures, and then more object-oriented programming. We use C++ for this, but again, it's still in this sort of interpreted, immediately sort of automatic feedback environment. So it's really, the environment does not get in your way. And then once the students have these foundations in their first year and a half, they're able to take on things like advanced C++ and advanced Java. And then they can decide what path they want to go on. If they want to be an embedded systems programmer, they have the chops necessary to take on low-level, resource-constrained development. If they're very interested in high-level web services, they can easily go on that path to more and more abstraction, to building the software systems and to become the computer scientists that they're interested in doing and becoming. All the way throughout, it's all about problems. We introduce really interesting problems. We have them develop as part of larger software systems. We have them reuse code. Nobody builds anything from scratch anymore. We shouldn't encourage our students to build, the fundamentals over and over. We should be able to use libraries and support that normal program developers do, but they have to understand what's going on inside them. And so we include pair programming, test-driven development, all from day one. These are the processes, the software engineering processes, if you're familiar with them, that really encourage team-oriented development, really encourage bug isolation early in the process before the thing gets too complex. And it really is much more of a social interaction than an isolated one. And I think that's key to encouraging and retaining the next generation of computer scientists. We have a project-oriented, team-oriented, large-scale, project-oriented, design-oriented software project that'll come later in the sequence. This is, again, continuous team development, communication of ideas, test-driven development, debugging all throughout so that it's all integrated. And then again, like I said, once they have the foundations, they can go to the higher level languages. And now they can launch also into our upper division, which allows them to take systems courses, operating systems, and compilers, as well as high level parallel programming and internet computing like classes. And so that's the entire curriculum. And then again, this computer organization, I just listed it last because it goes in order of the numbers, but they can take it early, so it's not, they can, again, introduce this abstraction, levels of increased abstraction over time. So just to summarize it, I think our faculty is very much dedicated to both high quality research and to producing very successful and top quality undergraduates. And so right now we've really invested the last couple years in laying the groundwork to do so. This is a process. It will take time. We will get things wrong. We are evaluating constantly and continuously to try to understand where things are falling short and how we can improve. But I think there's been a tremendous investment by our department, and we will continue to hopefully build on that from going forward. So I'll take any questions if you have them. I also make sure that you have the slides in case you wanted to see the more details. We have all this stuff online as well.
Well, for those of you that aren't